So, hello everyone. Thank you for being in this talk and visiting it. Just shortly before I come to the talk, a little bit about me. I'm Florian. Hi. I used to be very active in the Ruby and Elasticsearch scene a couple of years ago. Maybe someone has heard my name from that. I'm mainly known as doing event organization and community work, less than actual programming project work. I spent my time professionally as a Rust and Elasticsearch trainer, running my own little company. I organize a conference called RustFest, and I'm part of the Rust project that I'm going to talk about in the community team, and since recently, a month ago or so, in the leadership of the events team. The Rust program language has an events team, and I'm going to come into that. As a hobby, I shoot arrows at stuff, mine during the Q&A. So, I'm in management of a programming language, whatever that means. The title of the talk is 3 Years of Rust, which kind of indicates that I'd like to talk about the project a little more than about the actual language and about our experience over the last few years. The reason for that is that I found that the impression of such projects for people is extremely localized to the angle they are approaching the project, and often doesn't tell the whole story, to the point where I was, for example, recently at a conference as an exhibitor. So we were there with a small booth, and someone approached us and was like, oh, wait, this language is in actual production use. We're like, yes, since like 3.5 years or something like this. And these kinds of experience I have quite regularly, that people don't actually have a model of the products they're interacting with, and that's kind of sad.
There you go.
Yeah.
Are you using Keynote?
No, but as long as it registers as a mouse, that's fine.
Okay,
There we go. It works.
Yeah.
Okay, but before I'm talking about the project, for those people that have never heard about the language, I would actually like to introduce the language. Who here has ever had a look at Rust? Okay, quite a couple of people, but still quite some where I need to give a little bit of an introduction. So what is Rust? Rust is a new systems programming language that powers and was developed along with Servo, a new browser engine by Mozilla Research. Servo is explicitly a research engine, so some people believe Servo is the next Firefox. It is not. It is not intended to be, and it will never will be. It's developed by Mozilla and the community, and the first release was on the 15th of May 2015, so roughly 3 years from now. Next month's our birthday. It is therefore providing an alternative to C and C++, but also to higher level languages. And its credo is safe, concurrent, fast. It's generally perceived that safety, especially memory safety, comes at a runtime cost. That's why the credo for us is actually safe, concurrent, fast, big three. The core features of the language are, it has a static type system with local type inference. It has an explicit notion of mutability, so you have to select if something is mutable or not, and the language knows about this and makes conclusions using that. There's something that we call zero-cost abstractions, which means it has higher-level abstractions that may seem like a higher-level language, but when we have these, we make sure that they compile down to something which is basically equivalent to your best handwritten code. It has runtime independent concurrency safety. I'll talk about that for a very short while in a second. Errors are values, so there's no exception handling. You pass around any kind of error as a normal value. There's no null to avoid any kind of problems with nullness. It has something that we usually refer to as static automatic memory management. So it feels like the memory management is automatic, but it's actually all happening at compile time, which brings me back to this that the perception of memory safety is that it has a runtime cost. We don't use a garbage collector or anything like that for that. It's completely through static analysis. So what does it look like? This is a piece of Rust that opens a temporary directory, opens a file within it, and if it can't open it, it actually crashes in a safe fashion. It just aborts the program in a controlled fashion. So the language feels a little bit like C from the general syntax. So it has curly braces and all of that. It also has a notion of algebraic data types, like, for example, functional languages have. So for example, if you open this temp dir, this is a fallible operation. So after that, you would have to check, has it worked or not, using this match syntax, matching between the options OK and R. When it was OK, you would get the actual directory handle. The same goes for creating that file, which might fail or not. What I mean by this static automatic memory management, once all of these values drop out of scope, they will be removed from memory automatically for you. So the scope is the time that some of your data is alive, and it's fundamental to how the language works. The first base concept that the language is based on is any kind of mutability. So here's a small example. I have a data structure that in itself holds a data structure again, inner data, which in it has a number. I can construct that. This is the construction syntax. Assign to it. The compiler will complain about it though, because it says cannot assign to immutable field d.inner.val. The interesting thing here is it's the binding that's immutable. So D, because D is not mutable, I cannot mutate anything that's inside. So it's not a property of the structures, it's a property of the location where I use it. Here I'm saying I want to have immutable data. I could have immutable data somewhere else. And I introduced that by actually telling the compiler this is mutable, and now I can change it. The memory representation of this, for anyone who has ever used C, is kind of like natural. The structures and structures just lead to a packed memory representation, so this ends up being an integer in memory through a bit of semantic interaction. On top of that, it has two other base concepts, and this is ownership and borrowing, and these are the most important parts of it. Rust, sometimes at the beginning people said Rust is hard to learn, and one of the problems of it is ownership, like talking about ownership of data is something that people are informally used to, but not formally used to, because there's no other programming language that really does it that way. So the very first basic concept you hit in Rust is new. So it takes a while to finally click on how it's important. And the way that works is every piece of data in Rust is uniquely owned. And this, for example, makes that memory management work, because when you know that it's uniquely owned, when it drops out of scope, it's gone. It's basically reference counting, but you can only count to 1. And that's statically solvable. The compiler can do that for you. Ownership can be passed, and when owned data reaches the end of a scope, it is destructed. So here, for example, again, I'm opening a file, and I'm taking it, and I'm writing to that file, passing it over to take and write to file by a value to another function. And I write to the file, hello accuconf. The rules that I just explained say, at the end of take and write to file, the file is destructed, the file handle is closed. The interesting thing is the compiler knows about this. So if you try to call take and write file again on the same file, this will be a compilation error. Now, this is a solid base, but it isn't very, like sometimes you'd like to pass things around and actually not give up ownership. You would like to call a function twice on a file. And Rust gives you an additional piece here, which is borrowing. You can borrow away to the access to one of these pieces of data, mutably or immutably, and you can do that mutably once or multiple times immutably. this is exclusive. So whenever you borrow something away mutably, you're not allowed to get immutable access to it at the same time, and the other way around. So speaking more on a systems programming language, Rust forbids aliasing mutable pointers, strictly. So the same here. I'm opening a file, I'm writing to the file twice, and the only difference is that I'm actually using a different syntax here. I'm using an ampersand to indicate a borrow, or if you're coming from the C++ world, this is basically a reference. And the mut, again, describes this as immutable one and not an immutable one. Following different rules, the compiler takes that into account. Basically, the problem we're dealing here with is shared mutable state. The problem with state is not that mutable state is evil, shared mutable state is a problem. And Rust solves shared mutable state in its base memory model. And this goes transitively. So for example, if I have a vector containing 3 elements, and I access one of the elements immutably, and then, while this is active, I'm trying to write to it, the compiler will actually error and say, you cannot borrow this vector as mutable to actually mutate it, while there's still an immutable borrow active. Classic problem, if I mutate a vector, it could actually be moved in memory, and the first pointer might end up being invalid during that time. So Rust checks validity of all references at compile time. It even goes as far as checking inner references. For example, if I have a structure which holds an inner reference to an integer, and I try to return it, and in this case, ownership says, because it's introduced within, because number is introduced within return reference, but you're trying to give away a reference to it through that data wrapper, it will actually know about the binding relationship between the two and will know that the inner reference will end up being a dangling one. This is obviously a trivial example, but in larger systems, this proof is total. So all references in safe Rust are always valid. The compiler message here will be, the number doesn't live long enough, and will actually tell me the borrowed value only lives until here. The Rust compiler is quite known for giving good error messages. We have 2 engineers that regularly work on that. All Rust functions not only signal data types, but also mutability, ownership, and interconnections between input and output types. This is quite rich. If you like working with functions, but would like to have a little more information in your function signatures, Rust is probably the language for you. And the interesting thing here is these properties hold and can be checked on large code bases of basically any size. This is one of the parts where it shows that the language comes out of an engineering culture that owns one of the largest C++ code bases in the world. So Mozilla, sometimes the language feels a bit, oh, this is pretty pedantic for a 2-3 line piece of code. It becomes very nice when you're working on a larger code base that all of these guarantees hold anywhere in your code. So you can throw an immutable pointer to a huge library, and you can be sure that the data at the end is not mutated at all. Rust provides a set of abstractions. On top of that, it has higher level abstractions through generics and traits, similar to C++ templates or Java generics, which I don't want to go into detail here. The syntax is pretty usual, so you have angle brackets for introducing generics and colons for introducing bounds on these generics. It's all rather standard. There's another feature in the language that is pretty often not mentioned, or more mentioned as a sideshow, but it's actually central. It's what we call concurrency without fear. And what's behind it is the language has an idea of values traveling between concurrent primitives. So For example, I have a counter here, and the counter is initialized with a field and an integer that is just set to 0, and then I'm trying to increment that counter, but in a threaded fashion. And I'm trying to pass a mutable reference over to these spawned threads. And the compiler will actually say, you're capturing a moved value, you're trying to get hold of a value from the outside, and you're trying to increment it. The problem is, because I'm capturing a value the moment I start the thread, I'm passing on ownership. I can only do that once. I'm trying to start 3 threads. How's that going to work? So this passing on ownership of the counter to threads doesn't work. No problem. There's solutions for that. Let's use some kind of data sharing, for example, a manual ref counter to do this. Rust provides that. We just start having we wrap our stuff in a ref counter. The ref counter API works through that, works by actually cloning all those handles. But that's a detail. The interesting thing is, suddenly, the compiler starts to complain, oh, ref counters cannot be sent between threads. Why? The standard ref counter in Rust does not synchronize the internal reference count. And the compiler knows about this. It expects you to use something that is concurrency safe and that, for example, uses an internal mutex or anything else which provides synchronization, in this case, an atomic integer or whatever. But the compiler knows about this and gives you a usable error message. So next thing we do, we're trying to use another kind of reference counter. And the other thing that the language knows about is, even if I were using another reference counter, I would still not synchronize on the value, which will bring Rust to the point where it will ask me to actually provide synchronization. So the compiler has an abstract idea of what it is of sending values to different threads, which is the sending of the ref counter. It also has an abstract idea of what it means to share data between threads, which would be synchronization. It has these 2 terms. Interestingly, while the sending and syncing part is part of the language, this idea, the threading API, for example, is part of our standard library. If you want to use your own threading implementation, you can totally supply that and you will get the same support. So it's not like the language itself has primitives, like thread primitives, that ensure this. The language itself has that abstract idea of sending and sharing data. It does, but you can apply this to whenever you implement a thread pool or whatever. For example, our standard library threads, they're an abstraction over p threads, but we're not sure if you actually want to use p threads. Or on Windows, they're not. They are abstractions over the equivalent Windows primitives. So, I was asked to make this session interactive in the CFP. So this covers my short introduction into the language. Does anyone have any questions on this?
I've heard a lot about Rust having good C interoperability.
Yes.
Can you drop it in as if it's calling an external DLL or something like that?
So the structures that are introduced, they're looking a lot like C structures. The structure, like the standard structure layout in Rust is not defined just because the compiler might optimize on that. But there's, for example, an annotation where you can say wrapper C, which would make that structure be laid out like C would. We're using LLVM, so it's using the backend to actually find out the structure of this. And then giving you the ability to just directly call into C and back. We support the C ABI for functions, so you have really zero-cost interoperability there. Also, we can compile to dynamic libraries if you want to go the other way around, dynamic and static and whatever. So we compile to your standard set of artifacts. Because it knows that RC is not sendable between threads. It knows that by the type definition. So the rule in the compiler is there's a couple of types, a couple of primitive types that are send and a couple of primitive types that are sync, and some even that are both. And it's automatically derived. And so if a structure holds sendable types, that will actually bubble up. RCs in themselves have this mutable counter, which is in itself neither send nor sync, and the compiler knows about this. So the compiler does this analysis and knows it cannot cross this boundary. And the error message, the error message in the end is custom. It knows when send and sync are involved, it gives another error message. But this is basically how it works.
Is that done by is it implementing certain traits, like a send or receive trait or something for ARC? Is that?
Yes. Yeah. Yes. So you would implement send and sync for ARC manually.
What's the name of the double pipe syntax?
That's a closure. That's a closure. It's a closure with no arguments because the threading API doesn't pass you any arguments. What it does is it closes over. We're heavily using the feature that they actually close over to move data into the closure. So the moment that I refer to handle, I will actually move ownership from handle to the thread. We're heavily using this moving ownership idea in the threading APIs, not so much in the in async APIs.
So does that mean that by constructing the closure, that will move the ownership into the closure, but that is not crossing the thread boundary yet, right? So only when you pass that into the spawn does the compiler derive that whatever the closure holds is actually a reference to something that's not shareable?
So the thing that happens here is actually doing every iteration of the loop, I do one move in a freshly constructed closure.
Yes.
Yeah, so.
It's the previous examples where it failed. Actually, the compiler introspects the closure to say, you have something here that you cannot pass into the thread.
That's the sending and syncing. That has nothing to do with the move. That's the sending and syncing part.
But it somehow derives that whatever you have in the closure actually
it derives it by knowing what you pass into the closure, but the whole movement part, like the moving part, is happening at the moment where the loop is run.
Yes.
Yeah. So the sending and syncing analyzes what is moved. The part where it says you cannot move that twice, that's a looping concern. Okay. Good. Yeah.
I don't know an awful lot about it, but I believe that one of the reasons that Fortran is still a thing is that C and C++ have the aliasing problems that Fortran doesn't have, and therefore Fortran code can be more efficient. Does what you've said so far mean that Rust should mean that we finally can get rid of Fortran?
Ooh, I always try to avoid anything that sounds like a language war.
Do you want us to do that?
Yeah.
We can have it for you. Outsource the language war.
Sure. There's multiple problems involved there. Because we're based on the LLVM, for example, for a long time had an annotation in which you could tell it, by the way, this pointer doesn't alias. Then it would miscompile because no one else was using that. So we had strictly more information. Yes, it is an advantage that we have that. Currently, there's, mainly because the language is young, there's no Rust-specific optimizations being applied at a larger level because of that. So yes, maybe that's an option. So I wouldn't be, hopefully. So when we're talking about performance for Rust, especially we're in the C, C++ area, depending on benchmark, you'll be faster, depending on the benchmark, you'll be slower. Sometimes it's C with GCC is faster, then comes Rust, then comes C with Clang. It's that kind of area. It's the same ballpark. So probably that's the thing that I will currently think about. Also, getting rid of existing code is a much bigger problem than just having an alternative language around. That's the reason why Servo is not built for replacing Firefox. It's the test bed where you don't have to build on a production system to actually figure out stuff before you port it to a production system. Okay, great. Which brings me to the main part of the talk, the 3 years of Rust, because we're a young language. But we already got a couple of things figured out. And the reason why I do these kinds of talks is anyone here involved in an open source project, in a larger one? Well, that's great. I'd love to hear from your experiences. Because one of the experiences I have is that actually not a lot of people have a lot of interaction about that, of what works for them and what not. So when I prepared this talk, I was kind of thinking on how to structure it, and I ended up with a lot of small snapshots from the last 3 years. And I tried to find a structure, and in the end I figured out I can't, because I'm also just one person somewhere, and the project is global. So maybe if someone else would have their number of snapshots over the last 3 years, it could be something completely different. Maybe someone would come up with all the compiler changes we had in between. So let's start at the beginning, when we were finally done, 2015. 2015 was, Rust is a 10-year-old programming language. It is as old as Go. And before that, it was a research language at Mozilla Research. And around 2014, someone at Mozilla decided, okay, people, maybe it's a good time to finally come up with something done. Mozilla is an organization that is very, very focused on actually building final products. So even when you are in Mozilla Research, everything you research has to be released every 2 months. Like a clockwork, because they consider releasing part of having software. If it's not releasable, it's not software by their definition. And that was also something that attracted a lot of people. It definitely has attracted me, because it meant, like, even though you had the chance to have a look at how a programming language is produced, Mozilla did it in the open. That was, first of all, the chance to see it before it came up with 1.0, and then also getting, like, kind of the feeling they're onto something and they actually want to use that for something. So it's not going to be the next language that you learn that never ends up being in production. And that was the air around the project even back then. Obviously, because of also a large sponsor that had a vested interest in actually using it. And that actually meant removing a lot of features. Rust had a garbage collector at some time. Rust had a very complex error handling system that did work through a system that was similar to exceptions, which sounded quite nice, but ended up not being something that we actually trusted. The standard lib was trimmed tremendously when everything that wasn't portable, everything that would fit, like the new goal of building a systems programming language that would be, that you could end up putting on embedded devices, which wouldn't fit that. Everything that was a trace of a runtime system, reflection or whatever, anything that would have been kept, needed to be kept around in the binary to enable that, was killed off. And that was only in the last couple of months. So this sudden push towards, oh, we have a date now, and we're going to release, and we're going to release on that date, is something that Mozilla is very good at, and that was very interesting to see. It gives you, in retrospect, also a lot of things where you can actually read up the old mails and see, why isn't Rust using a garbage collector anymore? Why doesn't Rust have classes? We had classes at that point. They were just not good. And also coming up with ergonomics and tooling around everything. The first thing was we established an RFC process. Even before the language was released, you can find it under rust-lang/RFCs. We now have over 2,000 of those documents that are trying out language changes just as a discussion. All language changes have to go through that. Obviously, a lot of them must be tried multiple times in the discussion, and some of them will fail, or someone will just give up on them because they don't find them interesting anymore. And the final release was, as I said, May 15th, 2015. And the package that we released was the Rust compiler, based on the LLVM. Cargo, a build and dependency management tool, along with a registry on that, which is Ruby gems-like. The author themselves actually wrote Bundler before. The problem in this kind of space is finding someone who wrote a package manager before and wants to do it again is pretty hard. This problem is solvable by money, and this is what I think that we have to have in Mozilla. Rust-up, a toolchain manager covering the ability to run things side by side, so similar to RVM or NVM, but it also manages the whole toolchain. So the Rust compiler is by itself a cross-compiler, so it also manages managing targets, sysroots, and build roots. So all of these kind of things. So it's strictly more than what Ruby or Node have. A documentation tool, complete with API searching functionality and documentation testing. It has a testing mode in which you can test all the examples that you wrote in your docs, which is quite neat. And a complete book, the Rust programming language, first edition. A bit of compatibility tooling. Rust GDB, which just ensures that the symbols read nicer in GDB. The actual features were committed to GDB, a Vim plugin, and at that time a VS Code plugin. As I just said, the Rust compiler toolchain is completely cross-compiler aware, and this is a good decision to do that early because that is hard to retrofit into an ecosystem. The whole Rust ecosystem at least has awareness of cross-compilation. The release cycle of the language is nightly releases, all 6 weeks. Nightly is promoted to beta. After 6 weeks, beta is promoted to stable. So the thing that we released was actually the compiler version for March. And we're currently at version 125. It has worked since then. The idea of that is that it ensures that you can actually go from version to version without having a changelog that, I don't know, runs a small highway or something like this. It also ensures that if people have new features coming up, for example, new cross-compilation targets, there's a reasonable time frame in which they will actually be, they can actually be moved into stable. The stability guarantee since 1.0, there's an RFC for that, and you can read up what it is. Rust is backwards compatible. The stable compiler only exposes the stable interface. So if you are downloading Rust 1.25 and you're trying to use any kind of experimental feature, it will tell you, I know about this feature, but I'm the stable compiler. You're not allowed to use it. CLI interfaces are considered an interface. So if you build any kind of tooling on top of Cargo, like on top of all of these tools that I mentioned, you can rely on their interface staying stable. The project management was also set up back then, and it is explicitly anti-benevolent dictator for life. We are a large group of people, and we have no explicit leadership in the sense of one person. There's a couple of reasons for that. One, for example, is that the inventor of the language is currently a product manager at Swift at Apple. So he's out. So we regularly had contributors coming and going and leaving their mark and in the language. The project looks fundamentally different than from Rust a couple of years ago. So this was kind of like coming out of the history, but also we're quite happy with it. The core team is a tiebreaker. So if there's any kinds of issues that we have a tie on, we have a tiebreaker. Most contributions, and this is something that people frequently get wrong, are from non-Mozillians. The project is hosted at Mozilla, but Mozilla has the tendency to have projects that factor in a lot of contribution, and people are quite good at that. Programmers at Mozilla are pretty good at reading, at actually doing code review. They're much better at that. And we already had close to 1,000 contributors in 2015, so that was definitely necessary, all of this. Rust grows teams on needs. The initial team was core, infra, language, library, compiler, documentation, community, and moderation, which is also I know of not many programming languages that actually have an explicit community team or an explicit moderation team or even explicit teams for their documentation. We found that actually just putting a label on those people and making sure that they have an email address where they can be addressed and an RSC channel where they meet or where you can actually approach them has helped us a lot. So basically these teams are mostly for communicating who's actually working on this. If you want to talk to people that are doing this, talk to us. Yeah, it raises awareness of people's work and makes them addressable. And back then, because we were a small project, we tried to figure out a couple of things to do low-friction community interaction. For example, we have a community calendar. It's mostly for meetups or whatever. It's run on Google Calendar. The rule around the calendar is send us an email with a Gmail address. We give you access to that. And from then on, you can put your meetup in there. And that's what it's been like for quite a while until someone came up with, oh, by the way, I could write a weekly newsletter where I just write about the most important issues and what's coming out with a project. The newsletter now is up to 250 editions. It's running since 3 years. But for example, this one consumes the community calendar and says, well, every week, I'm just going to see what's coming up in the next 2 weeks, has a little script, puts it in the newsletter. So the meetup organizers just put stuff in the newsletter, and we're running a little script, sending the newsletter away. And suddenly, everyone who subscribes to our newsletter knows if something's happening in their area. We have an email address that's called community@rustlang.org, which explicitly is for, if you have any kind of question, ask us. Because probably community people doing community work for a programming language know the community a lot better than any other individual in the group, which happens to lead to situations like, oh, I'm the meetup organizer of Montreal. Do you know anyone? I don't know anyone in the city who could give a talk. Yes, our keynote speaker of our conference is living like 2 roads down. It's as simple as that. Most of these interactions don't get much further than that. Send a question, we send you off. Someone coined the term of, we're the Rust language's switchboard. And obviously we have forums, IRC channels, and all of these kind of things. You should totally have them. Also, nowadays, there's so many providers for that this is pretty easy to set up for any kind of project that has more than a couple of people. And you usually find someone who wants to do the moderation work and make sure that the IRC channel stays friendly. The other thing is low friction contribution. People want to contribute, and a thing that a lot of projects fumble on, and I don't quite understand why, is most projects have no tasks for people that just have 5 minutes at a time. The reason why I'm doing the switchboard work is I've got a company, I've got a job, I've got clients, but I'm on the train a lot. So while I'm on the train half an hour, I can totally write some emails for the project that I want to support. Building a compiler feature? Not so much. So caring about that has helped us a lot. And totally also avoid any kind of lingering tasks. So people that want to contribute don't really appreciate if it takes 4 weeks to just get a reply. So it goes as far as that we have a bot that checks if someone is a first-time contributor, and we make sure that we're early on site, just to make sure, because they probably have far bigger question than someone who is a repeat contributor. And often also far easier to answer questions like this goes here, this goes there, and maybe you should talk to that person. We do actually have expectations on tone. Our conversational tone is friendly and focused, not very bike sheddy and non-insulting. Stating issues is great, just as long as people are realistic about fixes, something you just can't fix next week. But we're working on, and we're also completely fine if people call us out and not working on them. People often fear that this is kind of at odds with people that are sometimes a little grumpy, stern, or something like that. That's fine. Grumpiness is not overstepping or something like this. We're very happy we have a lot of grumpy people around. This is perfect. It's a technical project. We're very happy with the stern discussion on a technical subject. Great. It's just that we found that whenever it goes into the area of being actively insulting, you got a problem, because people start engaging in discussions, and especially people that you would like to have in the discussion. Still, it's a young language, so the usability of the language was more like Rust was a usable contender in the programming language space back then, but a lot of things were missing, most notably libraries. So it was basically a language for people that would, in their free time, write stuff based on libc and nothing else. So a couple of these things were coming up pretty often, were pretty early, a serialization, deserialization framework, but for example, a lot of notable networking stuff was not yet written. So the conclusions from the first year are good tooling, having good tooling early helps. Establishing a productive environment is work, and non-programming work is a substantial amount of running such a kind of project, and it has been incredibly beneficial for us to be very early in crediting that, because people are surprisingly willing to give free work to projects, especially to Mozilla projects, but they would really like to get their little bit of fame for that. So any questions up to here? I'm going to stop after every year.
You mentioned you have teams that do core work and other works, and as well as teams that do documentation and community work. What's the ratio on the amount of people doing one or like more developed kind of work and more the organizational kind of work?
It changes from time to time. So it's a bit of a, in the organization that we're in, it's a bit of a fuzzy question. For example, if you work on infrastructure team, you're probably mostly talking to where do I get my service from, where can I put that stuff on. We're running one of the largest, now running one of the largest build farms for an open source project, because the LLVM just compiles very long. So this is kind of like an in-between between managing and that kind of work. The community team tends to be pretty big, because there's actually a lot of people that run a meetup and would be interested in doing something else for the project on top of that. So the ratio is probably 1/3, 2/3, something like this. And also pretty often the teams in itself manage work. So there might be people that build a piece of infrastructure. They're not necessarily in the infrastructure team if they have no interest beyond their piece. Because of that, we have quite a lot of contributors. So kind of the rule of thumb for a team is, for being in a team or being involved in a team is, you'd like to represent one of your topics actually to the other project, to the other parts of the project, which is mainly a management task, I would consider it. Yeah.
So 1/3 being the developer side?
1/3 being the people that do absolutely no development for the project. For example, I'm actually programming a lot for a lot of Rust on the job, but I actually don't like programming after my day. So my involvement in the project in itself is rarely lines of code. I'm also a bad compiler engineer. Okay, any more questions? Which brings me to the second year, finding adoption. And this is also, I used to do community management for the Ruby world before, and the one thing I missed in Ruby was the time when it found adoption of being actually involved. I was more involved later. So the interesting part here was, for me, to actually be in that. And I think it's very interesting to see how programming languages grow, because it's often hidden and often a very complex thing. The biggest problem is gathering data. So we ran a survey in the second year, which had 3,000 respondents. It turns out 20% of those respondents were already using the language at work, which everyone in the project was like, wait a second, I'm not doing it. Almost no one on the project does it, but there seems to be a lot of people that do that. And half of them in projects over 10K lines of code of Rust, like we explicitly asked for what's the amount of Rust code in your project, which is also quite interesting. Before that, we were expecting that most of the people that worked on larger code bases were basically working on Server or Rust-C. Proved us wrong. Also, the demographics. Rustaceans actually come in equal parts from dynamic languages, Java, Python, Ruby, classic systems programming, C, C++, sometimes D, or functional programming, like Haskell, Scala, whatever. And that was also quite interesting. So Rust tends to become an entry point of for people that would like to go back into systems programming. Pretty often, when we interview these people, they are like, oh yeah, I did it in university, then I ended up having a job in some kind of Rails agency, did a lot of Rails, later figured out that maybe I should rewrite parts of the system in maybe a faster programming language, but C isn't memory safe, which is why I crashed my whole Rails server. And suddenly there's a systems programming language that is memory safe. Interesting. So pretty often in these kinds of contexts, Rust is actually not used as, you don't build a whole project in Rust. You're actually building dynamic libraries and then calling into them just as you would with C. And the community is based in Europe. There was also something new. Like most of the marketing obviously comes from Mozilla at some places, so it's pretty often kind of biased towards US style of marketing especially. This is one of the things. And we have other huge groups in China, Russia, and India. This was also something very new to us. And we also conducted a production user survey shortly thereafter, after we found out we have production users in that size. And feedback was good, especially for reliability and pain points where as expected. So the production users were mostly really using it as an alternative language to C, a language to write shared libraries in, or for heavily concurrent code, such as servers, which was a good thing for us because that kind of gave us finally the feeling that the concurrency features that we have are actually useful in production. And projects tend to be really fully Rust, but important parts are. That was the time when Dropbox, for example, decided to rewrite large parts of their backend code base using the language, but that was more writing one aspect of it. The production user problems were library maturity and tooling maturity. Because they needed a certain piece of tooling, for example, for certain that we didn't provide yet, or a certain library for a problem that they had that just wasn't written yet. But in general, it ended up being problems of the kind of it's not there instead of what's there is problematic. And so, which ended up us adopting the practice of being more conservative was actually putting stuff like out finally and actually making sure that what we put out is really working. The nice thing is that businesses tend to be a very different crowd of users. They are very aware of context. So if you can plainly state to them what's not there and plainly state to them what's there and what's actually solving a problem, that gives them a kind of a feeling of kind of trying to figure out what it would give them to actually adopt a new programming language, giving them a bit of a feeling, might end up being either something where they say, okay, this is a manageable risk and we might write 1 or 2 libraries ourselves, or this is interesting, we'll wait for a year, that's also fine. So these kind of discussions were extremely useful. And we also have some kind of production user liaison, so production users can get access to compiler-related things or hints from the team without going through public channels. A lot of companies are a bit closed. Like they're open to talk about what they're doing if you're doing that in a personal chat. For those who are interested, we've got the Friends page. This lists all the companies that are using Rust in production that we know of and that submitted us their logos and a short description. Users are, for example, Mozilla, Dropbox I just mentioned, Chucklefish produces computer games, Chef, they are deploying Facebook, NPM. So if you download any kind of JavaScript nowadays, you are using Rust. And my favorite one, the Opera House of Dortmund. We used in Opera production. And over 100 others. So a lot of variety there. So, but in the end, how do we compare to others? And this is a huge problem that we have. We don't know. We don't know if that's good, because there's no data on where was Go. Like this is talking about we're 1.5 years in. Where was Go when we were 1.5 years in? Where was Node.js 1.5 years in? Where was C? Where was... No, like even if we run surveys, other projects have started to run surveys like last year or something like this. We have no comparison, so most of the comparison we have is our own surveys that we had. It's a really big problem. Like I can get all these numbers, we can get all these numbers. One of the ideas that we just had 2 weeks ago where we had an all-hands meeting was that we need a crystal ball meeting. It's called like that. Because there's effects where we have no idea where they're coming from because no one else has talked about previous experiences with that. So, yeah, I can give you all the numbers, but I don't know if it's good or bad. I don't know if it could be better. I don't know if we're actually faring quite good and we should concentrate on other things. Okay. What has helped on the community side is still working on integrating people. We're telling people that want to run a meetup to actually default on not having talk meetups, but on having kind of hack and learn style. Get people in a room, start working on projects, have people help each other. That's vastly easier to set up, that's vastly easier to run regularly, and you don't need extremely experienced people for that. Most people are not yet on the state where they would actually like to give a talk, or they don't feel like they could actually follow a talk, which also means they don't show up. But having something where they can just bring their notebook, attach a plug, do whatever they like, and get any questions answered by someone who's more experienced with them, or even just have someone else working on the same problem with them, that helps. We still have very quick review times for patches, and we're helping out wherever we can. This is something you can measure very well. There's services for that. I can highly recommend using them if you are a larger project that has a little bit of money for doing this. There's services that where you basically throw in any number of repositories and they tell you the median time of merging discussions or how long issues linger until there's the next comment. It's highly recommendable. And we also integrate people into the project quickly. So the bar of actually being involved into one of those teams is basically, as I said, you want to do something beyond your very personal aspect. 2016 was also the year where we started conferences. The European one is Rustfest, which I started. It's in Europe every half a year. Next one is going to be in Paris in 1.5 months. RustConf in the US every year, and Rust Build Rust also in the US. Interestingly, all these are organized by old Rubyists. Basically all the Rust community is run by old school Rubyists. It must be the first 2 characters in the name. I don't know. Interestingly here, they are community run and community sponsored. Rustfest does not run on Mozilla money, Rust Build Rust also not. RustConf a little bit more, but we're kind of making a point that if you want to have a community that holds up on itself without having the large sponsor around, we also need to do that within the community and outside of Mozilla. And the other thing is we searched for ways for supporting people online. We're on YouTube. That was sometimes during the night someone was like, oh, why not start a YouTube account and just get all the videos that someone has about Rust and use the republish feature of YouTube. So we got basically only have playlists that say this was at a conference in 2015, 2016, something like that. It's now our biggest social media outlet, and it's bigger than the Mozilla YouTube channel. It is around 10 hours of work per year. So if you're running a larger project and you're struggling with social media, YouTube is extremely good at social media. And they're extremely good at promoting videos, not always in a good way, but in this case, hopefully, yes. We've got a Twitter account. Twitter still works very well in IT communities. Also, especially if the account has a name for actually being useful. So you can post a question to the account, and it will either retweet it or maybe answer it. The person on the other side is actually the head of our documentation team. I don't know how many arms they have when they reach home or something. They must be alien, but the account is active, and that helps a lot. It's as big as the Swift account. We tried running a global hackfest where we tried getting meetup organizers run something on the same weekend where people could chat. Doesn't really work. It ends up with a lot of people randomly at the same time being somewhere in an office hacking but not really interacting, so there's no point at making that on the same weekend or something like this. It's a huge piece of effort for not much value. So that was definitely more effort than actually running the YouTube account for a year. And the Rust community, and this is not something I quite got a handle on, is there's a lot of people that like writing. And so there's always like tiny tutorials on everything around, which is also something that if you find out that people are doing this, put them on your website or something, have someone who actually goes through all of these and kind of arranges these. Content editing is a helpful thing on that scope. So the conclusions for that year, social media isn't a bad word. Absolutely do that. Find someone who actually likes doing that. If you have someone in your project who likes doing social media, it's nice. Actively speaking is way better than waiting. If you've got a question and if you want to know how people are using your project or what you want to go, where you want the project to go, actively ask them. And the bug tracker is only half of the story, because especially on the bug tracker, there's rarely any kind of people that do, like, the bug tracker is mainly hobbyists for us. It's pretty rarely production users. So asking production users is very useful. And again, a solid base is better than a lot of half solutions. This has been very good for us, and this is something that production users appreciate. Not there or working is vastly better than maybe there and maybe working. Okay, any kind of questions up till now? In that case, let's come to the growing pains. Because it's not like we got that all settled and we're just chugging along. It's just 2016 was kind of the year where we could watch things growing, and like at the beginning, growing isn't much of a problem. Hey, cool, people are adopting our thing. We've got to fill like one gap here, one gap there. Someone starts running a conference, but that's also okay. So yeah. The survey nearly doubled in 2017. We asked for stability that year. Over 90% never had an upgrade problem. From the other one, we know about 8% that they hit a type system bug, which needed to be fixed, absolutely. So that's painful, but in general, the whole thing with the upgrade story worked. Almost everyone uses our tooling, so it must be okay, at least. And from a couple of people we know that are not using our tooling, they are in organizations that have a global build system where you must use that build system instead of whatever the language provides. Google, Facebook, Dropbox, all of this. And people rate the tooling favorably. It's usually a 4 out of 5 or a 5 out of 5. Biasing towards 5 out of 5. Community, 99% of people have no issue with the community, and 75% of these see the community favorably. Was also surprised with the numbers, but that was what the answer was. Still, are these numbers good? We don't know. There's no comparisons. Maybe everyone who had an issue with the community just didn't reply to the survey and didn't want to invest 10 minutes in going through all the questions. So again, it could be that these are just perfectly normal numbers for a programming language that people are invested in. Maybe the numbers are the same for Go or Haskell or whatever. In this case, well, cool, I got the same. At least I didn't, like, at least we're not broken, but I'm happy about those numbers, but I have no good feeling on Is this a success, or is this just like the normal state in our community? I don't know. The other thing that we figured out is we don't know Rust as a project. Producing, and this is not the first time I encountered it, producing a language doesn't mean you won't discover yourself, things for yourself. One of my most beloved mails from the Ruby mailing list is one where the inventor of the language himself says, "Oh wait, that's possible, I didn't know." And last year we had quite a lot of these things. I was at a talk at Rust FUZZ Zurich where I was sitting behind the language designer, and he was furiously taking notes during one of the talks of what the speaker was presenting as an abstraction. So you will definitely, if you are working with something as complex as a programming language, you will figure out that some things you won't, that you won't discover all the things yourself, or you understand everything. Even the people that design the language, the rest of the project even more. There are new APIs, practices forming themselves, new ways of interacting with the language, making things smoother, more ergonomics, without actually changing the language, which is also a good argument for not changing programming languages too quickly, because some of the issues might resolve themselves because someone actually finds out how to make this, to use this feature in an ergonomic way. And also, how do we include, that should be how to include Rust into other projects is actually becoming the main question. We get a lot of questions of, I've got this project and I would like to use Rust, but I obviously can't port the project, so how can I include it? Which means that a lot of tooling around this will be written, binding generators and all of these things. So we'll get new patterns coming up, and especially it turns out that this ownership feature that I just described in the beginning, so at the beginning, a lot of people were like, yeah, ownership is interesting, but then there's this borrowing thing. 2 years later, it turns out borrowing isn't that interesting. And I just gave a workshop yesterday, whereas the final part of the workshop, I talked for half an hour on how you shouldn't overuse borrowing, because complex pointer situations aren't that interesting, because usually you would actually like to copy, which means you own memory, and you're talking about ownership. But ownership is suddenly starting to become used for a lot of things. There are statically enforceable state machines written using the ownership system. It's used to model device drivers in memory to make sure that people don't get like secondary handles on these kind of things. It's extremely useful in concurrency, because most concurrency problems kind of boil down to, oh, we didn't properly figure out who's actually responsible for this memory location. And ownership says you must always figure out who's responsible for this memory situation, for this memory location. So this is the vastly more useful thing. And that wasn't, this is still coming up in the community as more becoming a practice, that this is the interesting thing. How can I model things to ownership, not how can I model things with pointers? That also meant that we needed to rewrite the book. We have a second edition now, and this was a huge effort, and we're going to have a third edition by the end of this year. So this is a vast amount of this project, just writing how people should deal with that. Implementing the programming language is suddenly becoming a fringe task. It's like all respect to those people that actually do it, but on the scope of the project, the people that are involved in actually driving language features becomes smaller and smaller. People driving library features, that's a different thing. People thinking about the APIs, but actually still working on language features, not that much. And the other thing is, so now that we got all the bases covered, which areas should we focus on? Are we even solving useful problems? Like there's some people that totally want to use Rust in game development. All power to them, you can totally use it in game development, but is this is an area we should focus on? Like should all next ergonomics pushes be making the thing for game developers easier? Should it be making things for embedded developers easier? Making server development easier? Making network programming easier? This suddenly became a problem, which also led to us going like kind of in all directions trying to figure things out. And the other thing is hobbyist problems aren't necessarily production user problems. So I recently spoke to someone on a conference and he was like, yeah, I got like an embedded development environment set up and that took me the better part of an evening. So, okay. So how long was that? 1.5 hours. Okay, is it working now? Like, do you have any issues with that? No, it's like, it's all running fine. It's very great. It just took me 1.5 hours to set up. This is not a production user problem, because if you're in a company and someone tells you, it takes you 1.5 hours to set that up, the manager's like, good, bought. Because these, obviously for hobbyists, when you only have like 2 evenings to spend or even less each week, this is an issue. Still the question, is this an issue that you on a larger scale as a project need to cover, or is there a way to basically work for both sides, or is this an immediate issue? This will probably become less in the next 1 or 2 years, but is this an immediate issue or is something else an immediate issue? That was a huge problem in 2017. Still, talking about things that worked, our release cycle worked. So after 2 years, that's time to look back. We only botched one release, which was 1.14, where we accidentally made an API mistake. Otherwise, we had no larger issues. And it also turned out the benefit of actually being consumable, like having consumable changes, leads to people updating their compiler regularly. If it's like every 6 weeks, and if there's changes, we do deprecations. We do no breakage, but for example, we do deprecations in the sense of now this isn't an API you shouldn't use anymore, there's something else. People follow that pretty quickly. If that's a thing of 10 minutes to follow, people do that. And interestingly, we are a practices leader. People often don't see that, but the community interaction model that we have was adopted by Node.js. Swift and Ember projects now have an RFC process, and they copied ours. And our management model, in general, is taken interest in. So this is having management as part of the open source project very, very early, even before release, and not calling it in any way, like we say management like it should be said, it isn't a bad word, was very beneficial to the project. Still, because we're running that for a while, we are actually running into issues that other projects will run into. The RFC process is highly successful, and a lot of people are proposing things. That brings issues. First of all, on these kinds of forums, there's always people with too much time that swamp the process. There are RFCs that obviously have no practicality, but they are like written in a staggering amount of words into how we basically should throw it all away and Rust should be a completely different language. This is rather rare, but also there's people that on any kind of RFC they have their opinions to put in, which is okay. It's just a volume that you need to handle. Obviously, people are allowed to have their opinions, and we want them. It's just sometimes like the amount of volume that you need to handle gets staggering. But there's also people, because of that volume, that have no time to follow, and then they feel excluded. So you feel like, I don't know which RFC I should put my opinions on to actually just like give people a glance on what I would like the language to be. And this tends to be a much bigger problem. Like the ones above, if it's really bad, you can just ignore them. Or you just have someone who goes through that and is like, oh, that's interesting, that's interesting, that's interesting, and that not. These kind of things. But people that don't interact, well, you can't interact with them, and they're still frustrated. And the other thing is, when you're talking about an international project, non-English speakers have an issue to follow these kinds of discussions. First of all, native English speakers write much faster, they write much clearer, and when you're doing these interactions regularly, please check if that other person is a native speaker, because that might be that their arguments have holes just because they can't express them better. And it's a real problem if you have people that are very strong in discussion, that jump on all of these and have the habit of destroying other people's arguments for the sake of destroying other people's arguments. This is, even if people are speaking English fluently, something where they tend to struggle, and that leads to a lot of problems. And that was the ones that we run into that year. And they're not fully solved, I have to say. And we finally got adopted by Mozilla. By the end of 2017, we finally got into Firefox. The CSS styling engine is now powered by Rust, using a lot of the concurrency features. But before that, it was basically, there were small test beds, like having one of the URL parsers rewritten in Rust, like some small things, some of the media parsing, to see if, basically to see if the build system worked and if the integration worked. But this was the first time we were actually powering a piece of Firefox. And this is a piece that was ported over from Servo. So finally, Mecha Fox coming up. So the conclusion here, have a sense of accomplishment sometimes. That was really great for the project. And it's okay to, well, bake cakes and everything and have a Firefox release party and so on and so forth. But the other thing is programming languages are extremely complex, also to the people producing them. And that either may lead to a moment where you completely block because you don't know if you can actually move things. You get a very conservative, or you just have to, well, have the guts to do all the changes and have things in place to check if you're not breaking the world. This is one of the big problems. If you have a bug in a programming language, you're breaking the world. And also have some ways to identify issues early. So having these large management groups actually helps people that like management are actually good at catching these kinds of issues, because some people might talk to them about that and like express their feelings. And all of these are valid, and making sure to find ways on how to deal with them is important. Any questions up to now? Okay. Then I just go on and we just have Q&A afterwards. So, this year, the future is unwritten. One of our solutions for this RFC problem was we ran a blogging campaign. So, instead of having people search for a venue where they could put their feedback in, we called over Christmas for people to use January to write a blog post about how they would imagine the language to be, what would be your favorite thing. So that was kind of focusing all these kind of small feelings towards, this is the place where you can put them. And we're going to read them all, we're going to do a write-up of them all, we're going to decide on these, on this input. So they were encouraged to write down their wishes. So that could be, oh, here's a feature list I want to have. I want these RFC merged, or just something I would like to have a push in that direction. And that would also allow people to express things that are outside of the scope of the RFC process. For example, I would like someone to start a tutorial podcast, podcast for intermediate users. It certainly turned out that people were like, oh, beginner's documentation, that's quite good, but what if I'm already experienced with C++ and know my way around systems programming, and I would actually like to skip all of this. This is a structure, this is a memory representation, give me what's new. So these kind of things. And we got 100 of blog posts or essays. You can find them all, and that led to a community member coming up and say, oh, it would be cool if someone would actually build a website where these are all archived. So readrust.net is a project of a previously unknown community member. And we ended up being Stack Overflow's most loved language, third time in a row. Why? I have a running theory, we generate and manage both. Buzz. And Buzz is a great thing if you can back it with actual technology. I have absolutely no problem of saying I do marketing as long as I feel good with what I market. I I know marketing in the tech community is sometimes considered a bad word. It actually works. And I would actually like other projects to be better at that. If someone has any kinds of questions or knows someone who has questions about that, community@rustlang.org is also open for other open source projects. This is why we go to conferences and talk about these kind of things, because we would actually not like to participate in a language war. I think the resurgence of systems programming is an incredibly interesting thing. And we are currently at a place where, or at a phase where any kind of growth in that area benefits all these languages. Like a lot of the C++ features that we currently have or that are currently coming up are coming up because there's Swift, Rust, D, NIM, whatever. It's not just us. It's because there's interesting new ideas coming in, but obviously we're not here to kill all C++ code bases in the world. This is absolutely not the goal. We're here to giving another option. And if someone in the C++ committees feels like, oh, cool, this is something interesting, we're going to put that onto C++, I think everyone wins. And, well, people follow that buzz, and if they find something, they're happy. It's the thing. We have more teams now. We have 17 teams with over 100 people. 2 of them just spontaneously formed 2 weeks ago at the All Hands. One group of people that wants to do formal verification and another group that just wants to work on code generation. So this is like the granularity we have now. We have a code generation working group. And the community team split, for example. We have RustBridge, which cares about outreach and workshops. We have the event team because we have so many events that it makes sense to actually have a central group managing all the interaction with Mozilla, for example. We have a content team that does these, like, this directly comes out of that Read Rust project. Why not have a team that actually cares about all the stuff that people write and film and speak into their microphone? And the switchboard team, because that task has become so big, is now its own team. We're more than 20 people in the community management alone. Pretty often they're also part of other teams, but they're taking that on. Teaching Rust, interestingly, remains a problem. The problem there is teaching programming remains a problem. There's also no one who can give you any kind of conclusive answer on what works. It's all gut feelings. Some people say, oh, programming works much better when it's visual. Why? Is there a paper for that? Is there a study? Is there something? No, I do that all the time. Great. So it's all like anecdata, as they say. That's a huge problem. Any kind of new programming language that is a little more complex than JavaScript is always like, oh, don't use that as a first programming language, because suddenly you have to handle memory. On the other hand, we have people that come to the Hack and Learn and are like, I would really like to know how my processor and how my memory works. Well, don't teach them JavaScript. So we have no very good model of that, and that's also a huge problem for us. I'm training the language, and I have to say, I'm doing the best that I can, but yeah. So we would be very interested in talking to people about that. We are within a research group, so if someone is researching these kinds of issues, we can maybe even get to contact there. So the goals for this year ended up more tangible, though. We want to have a stable story for bare metal embedded, and this is probably going to be by August, which means you can develop using the stable compiler on a number of common devices. Cortex-M, STM, all of these kinds of common processes. We want to promote our rock-solid networking story. That's what we get out of our production users. They use it because it's rock-solid. So we want to promote that more. And the other thing is WASM. Taking the chance that we're actually sitting next to the people that standardize WASM, and WASM generating a lot of interest, especially around now we finally got a target that we can port between browser, Android, iOS, and our backend. Using WASM as a target in the browser is very, very useful.
Could you say what WASM is?
Oh, sorry. WASM is WebAssembly. which is a kind of an assembly language that runs within the in the JavaScript interpreter of your browser, and is a compile target that you can compile to. You can also compile C++ or C. Clang has support for that. We want to ship language ergonomics around an await-like concurrency syntax. Currently, Rust has no concurrency support in the sense of having syntax. We have this kind of type level feature, but that's not syntax. And around boilerplate, the code name for that is Rust 2018. That might involve opt-in language breaking changes, so you would need to port a Rust 2015 code base over, but you can mix 2015 and 2018. So you can build a library with 2015 and then consume it in 2018 code. We want to have a conference on every continent by 2019. That's a stated goal. And we want to make people aware that the language is actually adopted, because that tended to be the biggest problem that was coming up around winter or something, that actually the language has seen far more adoption and far more use and far more productive use than a lot of people are aware of. Well, the conclusion for the beginning of this year is actually rework your organization regularly. Having a lean process also means you can regularly rework it and change your approaches along with it. Don't change that just because you feel like it would be better if you had these kinds of teams. The reason why the community team split is actually because people said, I'm not coming to the meetings because most of the subjects are not interesting for me. That's why the split is there. So we have individual meetings for all these kind of teams, and then we have a regular meeting where we just say what the teams were doing and see what it unlocks. It really helps if you don't have a too strong hierarchical group in an open source project. Hierarchy doesn't work because of the time zone shift, for example. Like if you got a hierarchy and the person in San Francisco is calling the shots, maybe someone in Europe can answer, but someone in Australia, they're out. That really helps. Okay, any questions up to now?
When you asked people to write blog posts about their hopes for Rust in the future,
yeah.
How did you find out about those blog posts?
We actually called for them.
So they submitted them through like a form on your website? Or what?
We had a call for blog posts on our project blog and promoted that through our channels of telling people, please send us an email. And we also, please send us an email or a tweet or something, and our teams actually went, and everything that we got noted, we just had a Google Doc where everyone who called a link somewhere put it in. So there's a lot of manual process involved. We're working with a lot of markdown note services where people just put stuff in. There's not much technology behind that.
The reason I ask is, it sounded like you wanted people to kind of think it through.
Yeah.
And if you said, okay, like tweet and we'll find it, what happens if someone just wrote like one sentence in a tweet that I want this and just tweeted it at you? Would that get taken seriously, or was it?
If it were an audible thing, we would totally put that in. Yeah. So the range that we encouraged people was at least a paragraph, but that's fine.
When someone writes an RFC, who decides, or how is it decided whether that becomes part of the language?
That is finally a decision of the relevant teams. So if it's a tooling change, it's the tool team. If it's there's a couple of people that are allowed to vote on this. So there's a voting, but like the group that can vote on this is not open. So this comes out of a lot of the review processes that Mozilla has. The reason why we have this is actually to make sure that there's some vote at some point. So the way it works is someone from that voting group calls the time when the voting happens, and then you got 6 weeks of final commenting, and then this group votes on it. People make sure that there's ample discussion before. And for example, what people do is write, by the end of it, a conclusion of what they felt like the discussion arrived, so that people can reply and say, well, no, I did not mean that. It was actually meant the other way or something like this. So this is it's a pretty tricky process to set up. There's a whole rule set that you can read in the repository.
Have you had any really contentious RFCs then, like where the voting is pretty much split?
They're pretty often denied. So for example, when I'm talking about this language ergonomics, there was an RFC to rebuild the module system, which a lot of people felt like it was going too far. And that had to be tried 4 times. And it's a much thinner and much better RFC now. So the first 3 ones basically, okay, this is not going to lead to make a lot of people happy, or this is going to lead to a community split, is a good reason to deny an RFC. Even if some of this was even an RFC that came from the core, from core team members. So this means that anything that comes from inside of the paid people at Mozilla does not get preference. Okay.
So when you say that Rust is stable, is that stable in terms of like the feature set in the library? Would you also have a stable ABI?
So the Rust ABI in itself is not stable. Reasons are that it contains a lot of things. Similar to C++, it contains a lot of metadata about ABI templates and all these kind of things. The language is generic. You can, for a library, you can opt in to using the C ABI. So if you would write a library with a that generates a dilib, you would get like a normal dynamic library or a normal static library, and this one is stable.
Does that mean that you have to use unsafe Rust?
For what?
So when it becomes a C ABI?
So Rust has an unsafe sublanguage for interactions with things that cannot hold the guarantees of Rust. Having a library that exposes an interface is in itself not unsafe. The unsafety is on the consumer. If you want to call into C libraries, this is inherently unsafe. Just because the C language doesn't give any kind of guarantee. So you have to, so the compiler knows about, okay, there's something beyond here that I cannot expect to hold the guarantees that I.
So with Rust code with a C ABI doesn't count as unsafe?
No. You would have you could write a header file for that. There's header file generators, and then you would document, like just as your normal C API, you would document this is a pointer, this pointer needs to be unique or whatever. Or this will be dropped, we will deallocate this, and all these kind of things. But this is, for the Rust language, not a concern. Okay. Then, yeah, finally, large quality projects without a benevolent dictator are there and work. They are just very silent in that sense. We rarely have loud emails sent around. Which tends to be a problem. Like there's so many projects that I know. Ruby the same. Mods is nice, so we are nice is a saying in the Ruby community. So it's rarely that you hear about any kind of outbursts of mods. He's still running a global programming language community. So yeah. And finally, thanks to the LLVM project, we wouldn't live without them, the Ruby, Python, and Mozilla and JavaScript communities, because we apply a lot of their work. So a lot of this is basically people that came from other projects, and they're like, cool, new project. Finally, I can build it, like we can build it without like rearranging the tables. We can finally just paint the room fresh how we like it and put our furniture in. So, thank you.